All right, students, so we are looking at the law of sines today. We're going to look at the formula, how to get the formula, and how to apply that formula on some basic problems. So before you know the law of sines, something that you knew how to do was when you have maybe a right triangle with an angle of 40 degrees here and a hypotenuse of 15, you could use sine and cosine to find those other missing legs, and lots of variations on this. The type of problems that we're going to be dealing with now are triangles that are not right triangles. So maybe a triangle that has angles of 40 degrees, 80, and 60 degrees, or something, some other variation. And I'll tell you one of the sides, but we don't know those other two sides. And you might say, well, can we use sine and cosine? And the answer is no, we can't, because sines, cosines, and tangents are based on the fact that you have a right triangle, and the sine of 80 is the opposite over the hypotenuse. When you have a right triangle, it has to be the opposite of the hypotenuse. It's not true of a non-right triangle. So unfortunately, sines, cosines, or tangents are out in their traditional form, but we are going to identify a formula that actually gives us a really nice way of finding those other sides. And that formula is called the law of sines. So let's get going. Rather than dealing with specific numbers, we're just going to draw a triangle and put some letters here, and then what we do here for this one triangle, then we'll be able to say, well, this is true for any triangle. So here we go. We're going to have just some generic triangle, ABC, and across from angle A, I'm going to put a little a. Across from angle B, I'm going to put a little lowercase b, and across from C, I'm going to put a little c. And I'm going to draw a dash line here showing the height or the altitude there with a little perpendicular. So that's great. What we're going to do first now is focus in on this left triangle, which, what do you know, happens to be a right triangle. So because this is a right triangle, we can talk about the trig ratios. So for instance, if I say the sine of angle A, we notice then that would be the opposite over the hypotenuse, in which case that would be letter H over C. And at the same time now I'm going to focus in on this right triangle over here on the right, and we can say the sine of angle C would be the opposite over hypotenuse. That would be H over A. And then I'll modify both these equations. On this equation over here, I'll multiply both sides by C to cancel out the C, so I have H equals C sine A. Over here I'll multiply both sides by A, so I cancel out the A on the right hand side, and so I have H equals A sine C. And then you'll notice in both of these equations I have an H, so therefore C sine A must equal A sine C. And that's what I'll write here. I'll just link these two. C sine A equals A sine C. Since they're both equal to H, then they're both equal to each other by the transitive property of equality. All right, and then we can say, let's divide both sides of this equation by A to cancel out the A on the right hand side. At the same time, we'll also divide both sides by C to cancel out the C over here on the left hand side, so we end up with a nice formula here, namely sine A, so the sine of angle A over little a, is equal to sine of angle C over little c. And we're just going to hit the pause button on that right there. Draw that triangle again. This time still ABC in that same orientation. This time we're going to draw H going up here to this other side. So across from the A, I'm going to label it with little a. Across from the B, I'll label that with little b. And across from the C, I'll label that with little c. And of course that distance there between angle A, the perpendicular distance rather, and this length over here, little a, I'm going to label that as H. So now we're going to focus up on this right triangle here. I know it doesn't look entirely proper, but that's because I'm not good at drawing that to scale here. So anyway, thinking about this, we've got, if we say the sine of angle B, okay, would be the opposite over the hypotenuse. So that would be equal to H, there's the opposite, over C. I was going all the way down to there. That's not right. It's this triangle right here. Now we're going to look at this right triangle here, and we'll say the sine of angle C, that's going to be the opposite over the hypotenuse. You can see the hypotenuse is this over here. So sine of angle C is equal to H over b. So just like we did over here in this previous part, we're going to multiply both sides by b. So I have b sine c equals h. We multiply both sides of this equation over here by c, so that I have c sine b equals h. And once more, we have two things that are equal to the same thing, therefore they are equal to each other. So I'll say c sine b equals, I'll make sure that's lowercase c, b sine c. In order to simplify things, I'll divide both sides by b, and then I will also divide both sides by c to cancel that out. And in a little bit simplified form, we have sine b over b equals sine c over c. And you will see that here we have sine c over c, and sine c over c is there, so that means that we could put sine b over b. That should be a lowercase b. Sorry about that. So we have sine a over a equals sine c over c equals sine b over b. And, that is our law of sines formula. And basically what that means is that I can pick any angle and then divide it by a side, and that's going to equal another sine of another angle divided by the side that's across from that. All right, let's go ahead and get to some problems here. So I think we'll do two problems. You'll probably get it after the first problem, but here we go. Here we have triangle ABC, and let's say that we are told that angle A is 37 degrees. We'll go and label that. Angle C is 100 degrees. We'll label that. And little b is 8. Obviously not going to draw on to scale because in this picture 100 looks acute. Meanwhile, the measurement indicates to us that it is clearly obtuse. And we are told to solve the triangle and round our answers to the nearest tenth. Hooray! So here we go. We're going to just write down the law of sines. Now I can pick any two. I could say sine A over A, sine B over B, sine C over C. I want to figure out what little a is there. So I'm going to write sine A over little a equals, and then over here I need to make sure that I've got something that I do know, and I'll put sine B over little b. And you might say, well, wait a second, well, we'll get to that in a second. Let's start filling in some numbers here. Sine A, so sine of 37 degrees over little a equals sine of b. And we say, oh wait, what's b? I don't know. Well, I do know that if you have all the angles in a triangle, then they must all add up to equal 180. So let's do 100 plus 37, which is 137. Let's subtract that from 180 degrees. You get 43 degrees. So this angle is 43 degrees. That wasn't too bad. So sine of 37 over a equals sine of 43 over 8. Notice, in order for this to work, I have to have 3 of those 4 pieces of information. And now we're off to just doing some algebra here. I want to get this a all by itself. So first off, I'm going to multiply both sides by a. That way it'll cancel there in the denominator. And now I need to get rid of this 8. So I'm in the denominator here. So I'll multiply both sides by 8. And I want to get rid of the multiplied by sine 43. So I'll divide both sides by the sine of 43. There you go. So just to write this left side all in one long sentence, 8 times the sine of 37 divided by sine of 43. And that's great that I haven't done any rounding because I'm literally just going to type that into the calculator and hit enter. And what do you know? It's approximately 7.1. So I'm going to make a little summary here up here. Little a is 7.1. And now I need to play the game again, solving for little c. So sine of angle C over little c equals sine of b over little b. Angle C is 100 degrees, so sine of 100 degrees over little c, which I don't know what that is, equals sine of angle B, 43 over 8. Notice whenever you're doing this, I could have put sine of angle A over little a. However, little a was an approximated value, and I want everything here to be as accurate as possible. So I'm going to go back to dealing with b because that was the information that was given to us. And anytime that you have an opportunity of using given values rather than calculated approximate values, go with the given values. So I'm going to get that c all by itself. Multiply both sides by c. Check. Want to get rid of that 8. Multiply both sides by 8. I'll erase the 8 from last time. I want to get rid of that times sine 43. So divide this by sine 43. Divide this side by sine 43. This kind of got a little messy, so I'll clear it up for you. So c is equal to 8 times the sine of 100 divided by the sine of 43. I could have done this in multiple steps, but I feel like you kind of see what's going on there. Type that in a calculator, hit enter, make sure you're closing the parentheses after the sine of 100, and we get 11.6. So little c is approximately 11.6, and angle B was 43 degrees. Those are the three pieces of information that I needed. They wanted me to solve the triangle, so now I have all the angles and I have all the sides. All right. And this problem is very similar. Don't really feel like it's 100% required for me to narrate it, so I'll just kind of let things go here. I guess I'll narrate it for just a second here. All right, so first we're going to find the measure of that other angle by adding, add the 66 and the 83, and we get 31 degrees. Then we need to figure out little a and little c. So I'll start off sine a over little a equals, and I want to use one that I already have. I don't know what little c is, so I've got to choose sine b over little b. If you're not really sure what I'm talking about, and in the process of this you set something up and you end up with like two unknowns, then you've done it wrong. You need to go back and check and make sure that your other ratio here is something that you already know, that you already know the angle and you know the side. So see, I've got the 66 and the 4. Those numbers are already in, and I've got that one. These problems, by the way, I'm going to hit pause button real quick, are all situations right now that we're dealing with where we're missing a side. In the next lesson, we'll talk about what to do when you are missing an angle. And it's really the same exact setup. It's just that there's a special case that you've got to deal with that that crops up every now and then. All right, want to get rid of the a, multiply both sides by a. Want to get rid of that 4, multiply both sides by 4. Want to get rid of the sine 66, divide both sides by sine 66. Rewritten here for clarity, we have 4 sine 83 over sine 66. And just type that in the calculator, you get a nice approximated value of 4.3. I'll summarize that up there on the top left. I'll also write angle C is 31 degrees. I raced a little bit too much, so now I'm looking for angle C. So I'll say sine of angle C over little c equals sine of angle B over little b. And I've got number, and I've got a number here for that, so I'll multiply both sides by c, multiply both sides by 4, divide both sides by 66, kind of slow this down just a little bit to see what's going on here. Rewrite as needed. C is equal to 4 sine 31 over sine 66. You may be tempted at this point when you're looking at this to just try to create this equation right here based on the information that you've given. You're free to try it. In my experience, students that try to find shortcuts like that normally don't get it. Students who write it out like this and just take an extra minute to multiply and divide as needed get the answer the first or at worst the second or third time and then move on. So user beware. Plugging that in, we get a value of 2.3. I encourage you to try that yourself to make sure that you actually can get a value of 2.3. We're going to box it, declare ourselves done, have a nice little happy face. Good luck solving these problems. I wish you well.